Hello pre-calculus students, this is Miss Robinson again, and tonight we will be continuing our 4.3 notes, starting with example 1. So if you flip open to your 4.3 notes, turn to example 1, we will begin from there. So our instructions for example 1 are to find the remaining zeros of f. Okay, straightforward. For A, we see that our degree is 6, meaning I should have a total of 6 zeros. Whether those are real or imaginary, I should have 6 in total. And then I'm told my zeros. So I have I as my 0, 3 minus 2I as one of my zeros, and negative 2 plus I as one of my zeros. This only gives us 3 zeros, however, and we know that we need 6 in total, so we need to consider the information we're given and how we could find additional zeros. So if we think about having these imaginary complex zeros, we might remember a theorem we had earlier in the notes. If we go back to the page just before and we look at our conjugate pairs theorem, our conjugate pairs theorem told us that if we have a polynomial and we have a 0 of the form a plus bi is complex 0, then we should have its conjugate as well, a minus bi. So if a plus bi is a 0 of f, then its conjugate a minus bi should also be a 0 of f. So for all of these zeros that I have here, I should also be able to have those zeros be conjugates as well, or their conjugates be zeros as well. So if I look at my first 0, I, and I think about the form a plus bi, I can see that I'm not adding anything, so my a is 0, and my coefficient for I is just 1i. The conjugate for this, with the opposite sign in between, should be negative. So this tells me that my conjugate, 0 minus 1i, or just negative I, should also be a 0. So I should also have negative I as a 0 if I have I. Let's consider the same for the next imaginary 0 that we have. So this one is 3 minus 2i. I see that my a is 3. My b, my coefficient for I, is 2. Here I have the negative conjugate, the conjugate with the subtraction in between the two terms. So my conjugate that I'm missing should be the positive version. So I should also have 3 plus 2i as one of my zeros. And then I look at my last and final 0 I was given, negative 2 plus I. I can see that negative 2 is my a value, and then 1 is my b value, right? 1 times I is just I. And this right here is positive here, so it should be negative here. However, I see that I have negatives in both of these. So if I pull out that negative, my 0 is actually just 2 plus I. So I found these 3 remaining zeros by considering the conjugates of my zeros here. And if I add, now I have 6 in total, which brings me to the max, or the total zeros that I'm looking for in my function. Alright, moving on to B in example 1. This time we are given a degree of 4, and there's actually a typo on here. On yours you see that this is 2 comma, negative I, and I. This is actually supposed to just be 2 minus I and I. Okay, so we only have 2 zeros we're given. Here it looks like we have 3, so make sure that you correct this on yours so that you have 2 minus I, and I is your given zeros. Okay. So again, we're given these imaginary complex zeros, and we know whenever we have one imaginary complex zero, we also have its conjugate. So again, we're going to think about this form a plus bi, and we look at our first zero. So we have 2 minus I. If we compare this to this form, our a is 2, and our b is negative 1. We have I. So if it's a negative 1, in order for it to be the conjugate, it must be the opposite sign. So it should be positive 1. So I have my second zero, my 2 plus I. Okay. So that takes care of 2 minus I and its conjugate. I also have the zero I given to me. And if I compare this to this form, my a is 0 because it's nothing being added, so 0 plus. And then no coefficient is like 1i, so 1 for my b. Here it's positive 1, right? So here I would want it to be negative 1. So it should be negative I as my conjugate for that 0. So I know that my zeros are 2 minus I, 2 plus I, and negative I. And if I see, that comes to my total degrees here, 4. 1, 2, 3, 4 zeros for my polynomial function of degree 4. So that's all the possible zeros we could have. Okay, that's it for B. Pretty easy problem, very straightforward. Next we have example 2.